Good afternoon, everyone. Thank you for joining us today for our weekly Improving Talk sessions, in which our top industry experts share their knowledge for free. Our latest webinar series, Falling to Security, was designed to help teams strengthen their cybersecurity strategies in today's shits every month market. Whether you're maintaining older infrastructure or building new applications, this series offers timely insights to help you stay secure in a rapidly evolving digital landscape. My name is Armando Lopez from the Improving Mexico Enterprise, and I am thrilled to produce today's session. But now, let me talk a little bit about our amazing host for today, Mauricio Telles from Veracruz, Mexico. Mauricio is a Python technical lead from the Mexico Enterprise. He has been programming since the Timex 1000 computer. He's a big fan of the CLI and an Emacs and Linux evangelist. In his free time, he likes to play chess and cook. He is also learning to play the piano. In today's webinar, this XZ Util Deception, an attack on OSS you're probably using, Mauricio will highlight the pivotal responsibility of the open source communities and discuss how the trust-based model inherent to OSS can be exploited, among other insightful things. Before we start, please remember that we have a Q&A feature. Feel free to use it so you can ask Mauricio any questions and he will answer them live. And now, without further ado, I leave you with Mr. Mauricio Telles. The microphone is yours, my friend. Welcome.
Thanks, Armando. Hi, everyone. Good morning, and thank you for joining this talk. Today, I want to talk about something fundamental to our digital lives, something so pervasive yet often invisible that its compromise could shake the very foundations of our technological world, open source software, and the escalating threat of supply chain attacks. So let's start. I will discuss the XZ Utils backdoor. So let's start. What is XZ Utils? This is a collection of open source tools and libraries for the XZ compression format. These compression formats utility are very widely used in the Linux world, but there is also a port for Windows machines. The attack. A malicious backdoor was introduced to the liblzma library, part of the XZ Utils. The impact. Nearly granted its perpetrators authorized remote administrative access to millions of Linux systems worldwide. Because of that, it was assigned CVSS score of 10, the highest possibly indicating a critical vulnerability. This is very important because it attacks the SSH server, and most of the Linux machines use this service. So it was a huge thing. I will talk a little bit about the open source software workflow because it is very important to understand how this backdoor exploit the supply chain. So we live in a world with on software, from the smart devices in our pockets to the critical infrastructure powering our nation. So a vast, often unrecognized portion of this software is open source. And what is open source? Well, it is a computer software where the software code is publicly accessible, allowing anyone to use, study, change, and distribute it for any purposes. So this is a simplified workflow of open source development. And as you can see, developers identify a need, write codes, and submit a pull request to the project. And then the maintainers of this project review the code for the quality, provide feedback, and engage in a dialogue with the developer. And then they approve the maintainer approves the code and then merge the codes into the project code base, and then the cycle repeat to include new features. Usually the project is hosted in a software repository like GitLab or GitHub, and then developers forks this project. And then, for example, this has several benefits like lower costs, accelerated development, higher reliability due to many able finding bugs, increased innovation from diverse perspectives, and also flexibility. And more than 90% of companies use open source software as a component of their proprietary software. So it is very important, the open source software in the industry. Who is the perpetrator of this backdoor? It is known as Jia Tan, and there is something important in the software development cycle because many projects are so big and they have a lot of developers. So it is very difficult to the maintainer to know all the developers. And even now that we have tools like Zoom or Teams, most of the development is just using text like emails or tools like Jira, for example. So the project maintainer doesn't know face-to-face the developers. So this helps the perpetrators to do these jobs. So who is Jia Tan? This is an account name used to introduce the backdoor into the XZ Utils. And for example, it is suspected to be a pseudonym or a group of individuals working on behalf of state-aligned entities. And it also is a long-term campaign because the backdoor took almost 3 years to develop from November 2021 to February 2024. Jia Tan steadily gained reputation and trust within the XZ Utils community by making active, initially innocuous contributions. And this is very important because in open source project, you can start working, contributing to the project in several ways. For example, you can fill in book requests, you can create documentation, translating text, fixing books, and also making minor improvements. And after you do some of these action, the maintainer start to notice, and you can start gaining a more prominent role in the community. And also, we can say this methodical approach is a hallmark of sophisticated long-term attacks. The exploit uses coercion as social engineering. So what is social engineering? In cybersecurity, is the use of psychological influence to manipulate people into performing actions or divulging confidential information. It exploits weakness in human decision making. So this is very important, as we are going to see next. Jia Tan gained the position of co-maintainer of the XZ Utils project. This enabled them to sign off on the compromised version 560 and 561. As we already saw in the workflow of the open source software development, the maintainer is a very important role because he authorized the merge request, and Jia Tan being now a co-maintainer, he can approve its own contributions to the project. Also, there was a pressure campaign. The original maintainer, let's call him, received emails pressuring him to transfer maintainership to Jia Tan. And also, social engineering tactics were used. As an example of this, socket puppetry, using multiple online identities to create the impression of diverse support or opinions, often with intent to deceive. There are at least 2 accounts now that were used to put pressure on the original maintainer. They sent a lot of email asking to transfer control to Jia Tan because they say the original maintainer was not doing a good job. He agreed to transfer this ownership to Jia Tan because of this pressure. Well, technical ingenuity hiding the malice. I will not explain in detail how this backdoor works because I am more interested in explaining the supply chain attack. But this exploit uses sophisticated mechanism and also a multi-state injection for this to work. For example, nearly half of all malicious packages employ some kind of obfuscation, and they use encodings like base 64 or X to hide the malicious code. And there is an initial setup, and this initial setup uncompress some files and extracts information from those files. And then these new files were used in the stage 1. Then this stage modified again the previous files, and the stage 2 again modifying the previous files. So you have to do at least 3 stages to see the actual malware. So that was very ingenious. How the backdoor works? Well, they tailor to target specific distributions such as Debian and Fedora, which patch SSH demo with liblzma. And also they target for distribution that use the DPKG and RPM package managers. And how this works? Well, actually, they replace an existing function in OpenSSH, and this function load the malicious liblzma function that already talked about it. And some of the things that they used was to not use the Git repository to store the malicious files. They only use tar files and use these tar files to hide the vulnerabilities. And also they use binary test files to run some scripts. This is important because most developers use only the code that is pushed to the repository, but they don't look into the tar files. So that way they hide the malicious code from other people. And test files usually contains arbitrary data to stress the application, and they can have some garbage data to test edge cases, or they can use binary data to test compression algorithms. So if you try to open this test file, you only see a lot of garbage. You do not think that something is wrong with this. So that was also a clever approach to hide the malicious code. Attackers' long-term vision, sustained access, and further vulnerabilities. As I already told you, it took almost 3 years to develop these attacks, and they plan to continue working on the exploit because they increase modularity in version 6.5.1, and also they breaks the landlock functionality in XZ Utils. This landlock functionality is a Linux kernel sandboxing feature. So they try to bypass this sandbox to access the Linux system entirely. And also they use Git commit forgery because they publish some commits in behalf of the original maintainer. So this was also very interesting. There is no a clear sign of how they do this, but they actually do it. And how they exploit the software supply chain. I will define how to do that. For example, the definition is injection of malicious code into a software package to compromise dependency system further down the chains. Also, the attackers tamper with a product or its dependency so it carries a valid signature as is distributed through trusted channels. So, for example, in this case, we are talking about an SSH vulnerability, but the reality is that the vulnerability was on the XZ Utils library. So that's why it is known as supply chain attack. And also why they use open source software as target. And that's because modern software projects really rely heavily on multiple open source packages, and software supply chains often lack robust scrutiny, and hackers know that organizations are frequently unaware of the open source component in their environments and their vulnerabilities. So let's move on. And we have seen this before, and not only with open source software. These are an example of that. For example, there are 3 cases from 2017, and also in the 2021 there was a big vulnerability in the Log4j package. This was a critical flaw in a widely used login library exploited by nation-state actors targeting critical systems worldwide. And in this month, we have also another big vulnerability. This time, 12 NPM packages were used. One of them is the debug package. The vulnerability or the exploit for this package silently intercepts crypto and Web3 activity in the browser, manipulating wallet interaction and rewrites payment destination. These 12 package downloads by each week 2 billion copies. So it is a huge vulnerability. And then we have Andres From, the hero of this history. So how was this catastrophe averted? It was through the vigilance of one individual, Andrews From. And he was investigating an unexpected performance issue in Debian seed. And the performance issue was a delay about 500 milliseconds, but he was able to detect this delay. And he also observed unusually high CPU usage during SSH connection. And also he found that these SSH connections were causing errors in Valgrind. Valgrind is the book profiling tool. So he started looking into these issues, and then he reported his finding to the Open World Project, Open Source Security mailing list in March 29, 2024. So this incident highlights the power of the open source community, many Abel's principle, where if enough people look at the code, all bugs and malicious injections eventually become shallow. So this is one of the important things of the open source software that you have, or this is also a selling point. You usually hear that you can inspect the code and see how it is built, and you can find vulnerabilities, and also you can modify things if you want to. So lessons learned from this exploit, proactive security. The XZ Util backdoor was a profound wake-up call. It demonstrated the sophistication and patience of modern adversaries targeting the software supply chain. We must move from a reactive stance to one of proactive security. So we need to embrace software bill of materials, also known as SBOM, and SBOM document all open source components and their origins. Federal agencies in the US are now required to obtain SBOM from vendors of crucial software. At the beginning, when I heard back in the day about SBOM, I think they were something boring because you need to create a big inventory of all the dependencies of a project, and I think it was a waste of time. But when I started learning about cybersecurity, I understand the importance of these tools. So please do that in your organizations. Also, we need to implement rigorous code review and audits because, as I already told you, you cannot trust your developers in an open source software, at least at the beginning. All contributions, especially from new or less known contributors, must undergo stringent review processes. And also, we need to maintain robust version controls and timely updates. Let me tell you that 91% of code bases contain components with no new development in 2 years, and also 89% contain open source software more than 4 years out of date. So we must prioritize updating to secure version or rolling back to uncompromised version when necessary. You can use tools to automate the updates. For example, Automox is one of them. And also it is very good practice to always pin your package version so you don't get new version without note what these versions do. So continue with the lesson learned. We also need to strengthen defenses. We need to scrutinize supply chain provenance, know where your package come from, enhance maintainer security and awareness. Maintainers are a high-value target for social engineering, as we already saw, and multi-factor authentication, strong password, and training against social engineering tactics are vital. Also, we need to adopt automated security tools. For example, regular penetration testing, automating vulnerabilities scan, and continuous integration of security checks are essentials. For example, I have been working with CrowdStrike Falcon, This is an agent that you can install on your computers. It scans all the package running on that computer, and they told you how many vulnerabilities do you have, which one they are, and also it tells you the remediation for this vulnerability. So it is a good tool. And let's continue. Also, we need to implement zero trust architecture. Treats every component as a potential threat, enforcing strict access and controls and continuous monitoring for this. Community and governance. Beyond technical measures, we must strengthen the community and governance around open source software. We can support critical OSS projects because many critical pieces of cyber infrastructure depend on unpaid volunteers. So many companies or governments now are funding these projects. So the developers can focus on the quality of the software and try to do side projects, for example, to a living. Also, enforce compliance frameworks. And for example, governments and industries need to actively support these projects with funding and resources to ensure the health and security. And also, stricter guidelines for OSS users and adheres to robust cybersecurity practices are essentials. And foster community vigilance. Sharing trend intelligence among governance agencies, industry peers, and open source software community can help us collectively identify and migrate vulnerabilities. And when for conclusion, let me see, the XZ Utils backdoor was a wake-up call demonstrating the sophistication and patience of modern adversaries targeting the software supply chain. The trust-based nature of open source software, while a strength, also presents unique vulnerabilities that can be exploited through social engineering and technical ingenuity. Protecting our digital infrastructure requires a multifaceted, proactive approach, combining technical safeguards with robust community practice and increased vigilance. As the lines between proprietary and open source software continue to blur, and as our dependence on open source software only grows, the responsibility to defend this critical infrastructure falls on all of us. It's a collective effort for a shared future. So let me see. That's all. Thank you for joining this presentation. Before passing to the questions, let me share the next talk about this security series. This is the AI Accelerated Cybersecurity Landscape. What's changed? What's staying the same? This is next week, so please join that talk too. So any questions?
Hey, Mao, thank you so much for this presentation. It's been very insightful. And yeah, we have already a couple of questions lined up for you. And the first one says, is proprietary software more secure than open source software, in your opinion?
Yeah, it is more secure. I already told you. You have a lot of eyes seeing the code. With proprietary software, you don't know if they are using best practices. And for example, when there is a vulnerability, some companies try to hide the exploit. And I don't know. I think the open software is more secure, but you need to take several steps to make it secure. But yeah, it is.
Thank you, my friend. And the next one says, why were Debian and Fedora the exploits target?
Okay, that's a good one. And as I also already told you, the SSH daemon doesn't use the liblzma compression library by default, but these two distros patch the OpenSSH server to use that compression library. So the attackers were aware of this. So they only try to infect these distros. That way they don't break system that doesn't want to infect. Yeah.
Okay, and the last one we got says, how can I get involved in an open source software project?
Okay, there are several things you can do to start working with the open source project, but the first one is just to filling pull requests. If you are using a package, for example, I don't know, Inkscape, you can start asking for new features, or maybe you found some book and then you start filling book requests for that. And after that, you can start asking for another trivial tags. Maybe you need to translate some documentation to another language, for example. And after that, you can start reading the code and also start writing simple enhancements for the project. So that will be.
Thank you. Great advice, Mao. And we don't have any more questions right now. So I don't know if you want to share any closing remarks before saying goodbye to our audience.
I just want to share something. For example, I say that the open source projects are great to study the code and to learn from there. And when I start programming, it was a very long ago, and there was an internet, and the only way to get software was to buy in magazines, and you need to type the code from the magazine in your computer, and that way you need to learn a lot, because most of the time the listings in the magazine has typo or logical errors, so you need to find out how the program works and then start to modify it. And this is how open source works today. So yeah, this is something that I want to share with you.
That's great advice, and thank you for answering all the questions that our audience have, Mauricio. So that's all for today. We want to thank everyone for joining us this fine day, but especially my friend Mauricio Telles for such a great webinar, my friend. And as he mentioned in his presentation, coming up next week, the AI accelerated cybersecurity landscape, what's changed, what stayed the same, in which a panel of experts will explore AI-driven cybersecurity, focusing on insights, threats, and secure coding tips. It will be worth the wait. Until next time, everyone, have a great rest of your day. Thank you again, Mauricio. See you next time.